Good afternoon, everyone. My name is Nairika Bharucha, and I'm going to be doing my thesis presentation on my thesis titled Investigating Coral Reef Responses to Extreme Heating Events Along the Chagos-Laccadive Ridge Across a Gradient of Human Pressure. So I'm going to begin my study with a brief introduction on the threats faced by coral reefs. As we are all aware, coral reefs today face a number of numerous perils that threaten their very existence. Some of the most prominent threats to coral reefs are thermal anomalies, such as the El Nino Southern Oscillation, environmental stressors, such as waves, storms, and tsunamis, and local anthropogenic stressors, such as wastewater, nutrients, fertilizers, fishing of herbivores, and so on. Our study sites experience similar thermal anomalies and environmental stressors, but have vastly different local anthropogenic stressors. And we're going to move on to the aims and objectives. In a number of geophysical studies that have been carried out on the Chagos-Laccadive Ridge, no coordinated marine ecological study has been carried out on this ridge. In this study, we're going to investigate the effects of the 2016 El Nino Southern Oscillation related events on the reefs. And this study mainly aims to analyze the spatial variation in coral mortality and heterogeneity, as well as investigate if there's a link between them and the anthropogenic presence. We're going to use live coral cover as a proxy for reef health, degree heating week for heat stress, and for human pressure, we're going to use distance from the closest inhabited island and population density. My four main objectives are to see if there's a change in the benthic group composition before and after the 2016 thermal anomalies, to see if there's a change in live coral cover before and after, to see if there's a heterogeneity in prominent coral genera, and to see if the aforementioned three changes relate with the degree heating week, distance from the CII, and the population density. So we're going to go into a brief background on degree heating week before we get into our main study. We're going to be using degree heating week instead of sea surface temperature to talk about our thermal anomalies faced in 2016. So, bleaching threshold is the temperature at which corals start showing symptoms of stress. It's the measure of how far the temperature is above this threshold and how long it stayed above this point. Its units are degree centigrade week, which combines both the intensity and duration of heat stress into a single number. It was developed by the NOAA, which is the National Oceanic and Atmospheric Administration's Coral Reef Watch Program, and is commonly used when dealing with coral bleaching and events and studies. The DHW is based on the sea surface temperature and is taken on daily satellite images. It's a running sum measured over 12 weeks or 3 months and is done so on a biweekly basis. DH4 causes significant coral bleaching, especially to the most sensitive genera. And a DHW above 8 causes widespread bleaching and significant coral mortality. So moving on to the methodology. We're going to start by looking at our study sites. We have 21 sites divided amongst the three major island groups, the Lakshadweep, the Maldives. The Lakshadweep is a union territory belonging to India and is the islands located closest to the landmass. We've got 6 sites from 3 different atolls. The Maldives is an independent island country that lies further south of the Lakshadweep. Here we've got 5 sites from 10 sites from one atoll. And Chagos is the most remote of our 3 island groups. It lies further south. We've got 10 sites from 5 sites from 2 atolls. For each of these study sites, we carried out 2 surveys, one before and one after the 2016 ENSO events. Moving on to the benthic, I've carried out surveys using the photo-quadrant method, where a transect of 50 meters was laid on the benthic surface, and at every interval, a 1 meter square quadrant was placed and photographed. The benthic survey for the Lakshadweep was carried out by Dr. Arthur from NCF India, and the survey for Maldives was done by Dr. Sylvester from the University of Milan Bicocca. For the Chagos, the survey was done differently. Here, the survey was done using continuous video transects, and it was only a 30-meter survey. This was executed by Dr. Head from Zoological Society of London, United Kingdom. The image analysis was done as follows. For the Maldives, the photo quadrants were analyzed using the software CPCE. And here, the 1 meter square quadrant, which can be seen, was overlaid with a number of points. For the Lakshadweep, a similar analysis was done, but using a different software, IMBRSea. For the Chagos, the still images were extracted every half a meter using the VLC software. And the photo quadrants were then subsequently analyzed using CPCE, similar to the Maldives. The benthic fauna under each of these points was identified using a custom index, and corals were identified to genus, if possible, or else family level, using Corals of the World as a guide. For local anthropogenic stressors, we measured distance from the closest inhabited island. For this, we first recognize the closest inhabited island as a town, village, fishing, or farming community with permits to our study sites. Distance from each island to the study site was calculated using the direct line measure in ArcGIS. The population and area of each of these islands was obtained from their respective countries' latest population census records, and the population density was extrapolated. And we can see that for the Chagos, there's a large distance from the closest inhabited island and really low population density. This is so as the Chagos is one of the world's largest marine protected areas, and other than a military base at one of its islands, Diego Garcia, there's no other human settlement or activity, whereas Maldives and Lakshadweep are islands with settlements and tourism. Moving on to the degree heating. To obtain the thermal stress at each survey location, we got the annual degree heating week data for 2016 from the NOAA Coral Reef Watch website and overlaid it on a map where we had our sites mapped out. The value of the pixel of the DHW that coincided with our study sites was taken for the year 2016. And we can see from the following graph from ArcGIS that the Chagos had the highest degree heat. Chagos in the green had the highest degree heating week of above 12. The Maldives had an intermediate one between 6 to 8. And the Lakshadweep had the heating week between. We're going to move on to our statistical analysis. Summary statistics were done for our live coral cover, living, non-living substrates, algae, and key coral genera. As earlier mentioned, we had 2 time points for each of our study sites. One benthic survey was done before and one after the 2016 ENSO event. And here we compared the before and after sites using the following methods. To analyze the change in benthic composition before and after, we do an NMDS where we use the sites in the benthic groups and overlay it with an environmental fit. To assess the live coral cover, we use 2 GLMs. The first, where we use the live coral cover with each environmental variable individually. And the second one is a specific GLM where we use the live coral cover with the distance from the closest inhabited islands, but this is separated for each island group. To analyze our coral genera, we use an NMDS again, similar to the first, except it's sites versus coral genera. All the statistics were carried out in the R software. Moving on to my results and discussions. We're going to begin by looking at the benthic composition change. This is an MDS plot which positions sites relative to similar community compositions. It shows the dissimilarity in major groups of the benthic composition, as we can see. The island groups are divided by different color: red Maldives, yellow Lakshadweep, green Chagos, and the before sites are circles and the after sites are triangles. The sites from the Chagos have an extremely similar benthic composition to each other and form a distinct cluster at the bottom right. This also coincides with a high coral composition. The Chagos after sites have a dissimilar composition with a lower percentage of coral cover and a higher percentage of bare rock. For the Lakshadweep, we see that the sites 17, 19, and 21 are clustered together and have the highest algal cover, both before and after, whereas the sites 16 and 18 differ and have a higher rock cover. This can be so because these sites were on the east and the west of the islands. The sites on the west are the ones with the higher algal cover. These were on sites where there were lagoons, and the sites from the east, which have a higher rock cover, were on the outer side of the atoll in a more rockier reef. We next see that the more Maldives had a varied benthic composition with sand and rubble highly present. The NMDS stress was 0.12. It was weakly significant. And the degree heating week showed the most significant impact. As we can see, it had a value of 0.00. Unlike our live coral cover, we will first look at it visually. We can see that there was a marked decrease in the live coral cover in Chagos from 52% to 27%. In the Maldives, there was a change from 35 to about 25%, which was not so major. And the Lakshadweep showed the least change from 15% to 11%. This change in the Lakshadweep could be attributed to the fact that it was affected by the 2010 ENSO thermal anomaly, and it hadn't yet recovered by the time our first survey was conducted. The decline in the live coral cover sites significantly relates with all three environmental parameters. And that's why we see that all three of them show high significance, but this was not truly so. And this is just due to the fact that there was a high correlation between our environmental variables. To account for that, we carried out a further study where we divided our sites based on their island groups to see the localized site level variation. In this, we have a regression model where we have the live coral cover versus the distance from the CII, which showed to be the most significant change from our last graph. And we see the local patterns are opposite to the regional ones. Lakshadweep and Chagos show a positive relationship. That is to say that with decrease from the live coral cover, the decrease in the live coral cover increases with the proximity to the inhabited islands. In the Maldives, it's the opposite. We see a negative local relationship. And the overall pattern is negatively affected as well, since it deals with the we earlier discussed. We lacked data to carry out further statistics and more robust statistics for this, since we had only 5 to 10 sites per island group. Getting into my last objective, my coral genera diversity. We see a plot similar to the previous NMDS, where the colors and the shapes correspond as before. Lakshadweep has a similarity in both its plots before and after, and they correspond to genera such as Phosphopora, Platygyra, which were highly abundant in the Lakshadweep. The Chagos before and Maldives before sites are clustered around the Acropora. This tallies with earlier studies where we see that Acropora and other branching genera usually decline after a thermal anomaly. The Chagos after sites show a high generic variation, as they did with their benthic composition, and the Maldives after sites are clustered around the parietes. We also see from this model that the degree heating week has the most significant relationship, and yes, it has a significant relationship of 0.001 and is extremely significant. The distance from the closest inhabited island is less significant, but also did show variation, but this again was due to the correlation of environmental factors. Coming to my conclusions, there was a change in benthic composition for sure. This compositional change varied with the degree heating week, but was not significantly impacted by the anthropogenic impact. There was a marked change in live coral cover, and trends do suggest that sites closer to the human-inhabited islands showed a larger decline. But we lack data to carry out further statistics to prove this. There was a change in coral genera composition. Reduction of branching species such as Acropora and Phosphopora was seen. And larger species, stockier species such as varieties was seen. And this leads to a loss in leaf reedy structure, and that has a number of detrimental environmental and economic impacts. I would like to thank my promoter, Catherine Head, my supervisor, Dr. Yesin. I'm grateful to the Zoological Society for hosting me at the Institute of Zoology for these last few months. A huge thanks to Dr. Sveso and Dr. Arthur for sharing their data on the Maldives and Lakshadweep with me. I'm grateful to my parents, my peers, and the entire coordination team from IMBRSea for putting this great master program together. Thank you.